Hello, Ram. How are you?
Can you hear me?
Awesome. Awesome. Okay. We should be live right
Yeah,
now.
really so interesting day.
Oh, oh yeah. Are you okay? Is everything fine?
Yeah, now fine. No, but
That's good. That's good. I'm glad nothing else caught fire.
it was so interesting. Now we are in live or not?
Yeah, we're live.
Yes, okay.
Yeah.
Hey, Azar.
Iram,
How
how
are
are you
you?
doing?
I am fine.
Good to see you. Good to see you. How are you feeling?
Uh, good.
Yes. You got this. You got this. I have all the faith in you. Yes. It was such an awesome session last time. I'm super excited for this one this time, especially to be learning TensorFlow. It's gonna be amazing. It's gonna be amazing. And oh, Lazaro's here. Good to see you, brother. Oh. Everyone does hear us. Hi everyone. Hope everyone is having an amazing Saturday afternoon. And happy June, everyone. It doesn't feel like June, still feels like May, but you know. Let me give me a second. The live
Your
stream.
hair so looking good.
Oh, I'm sorry.
Your hair so looking good.
Oh, my hair? Yes. all over the place today. Yes, I have to cut my hair. It's been a little while since I cut it, and I tried brushing it to like be on the side today, but didn't want to cooperate. So we're rocking this style for now. And yes, it's a new emo style. Yes. Let me check. Let me check the live stream and see how everyone's doing on there. Give me 1 second.
Lazar, can you give me host authorization for Dida?
I'm sorry.
I gave both of you
Can
co-host.
yeah.
Do you want full host or is co-host good? Okay. Yeah, you should have it.
Yes. I'm really so excited again.
Yes, we're so excited too. This is an amazing series. Yes, and it's so fun. Let me.
can I share my screen? It's time.
Yes, you can go ahead.
Okay.
I think we'll try to start in about 5-ish, 2:05, if that's okay.
Okay.
Okay, awesome. Yes, to the people, Also, welcome to everyone joining the live stream. Hope everyone's having a great Saturday. Everyone's chilling, ready to learn some TensorFlow and yes, learn some more deep learning, get some hands-on applications, try to build some projects. Haha, it's gonna be a good time.
11% watch us.
I'm sorry. Yo. Hello, people in the chat. David, Farkan. What's up? India. Yes, Jassim. Good to see everyone. Yes, Hermes. Good to see you too. I'm sorry for the hair. Hope everyone is ready. Oh yeah. Yes. Where is everyone listening in from today? Please type in the chat. Yes, let's learn lots.
Oh, sorry. You are so super energy.
Have it? Oh, yeah. Yes, we're chilling. We're hyped. We're getting ready. Yes, and yes, we're all hyped. Yes. Well, maybe
Yeah.
maybe I should get like no. You know what? I just gotta own it at some point. Let's see, from Fort Lauderdale, Miami, Kerala, Massachusetts, Miami. Yo, let's go. That's nice. Yes, for all the Floridians and everyone around the world. Hope you're all ready. Yes, I am listening in from Miami, Florida myself at FIU headquarters currently. It's currently a nice Saturday afternoon, and it's been raining for past few days, but today it's not. So nice. Wow, Istanbul. That's so nice.
Istanbul Pendik. From Turkey.
Yeah. Yes, let's go. Yes, it's hype beast. Yep, hype beast behavior. Yeah, it's so awesome to see everyone around the world listening in. It's super exciting. Okay. I think we can go ahead and get started without, don't want to keep everyone waiting for too long. So yeah, I'll go ahead and get started. So welcome everyone. Welcome everyone to the second edition of the Deep Learning Bootcamp series. Zero to Hero, where you'll be learning today the basics of TensorFlow and even get started with a little project towards the end. And the one presenting this workshop today is none other than my good friend Irem Umurchu. Irem, you can go ahead and take it away. We're all excited to learn.
Keras, really, thank you. Hello, second week, and again, I see super energy, and really, I am so excited again, and like previous week. And first week, we talked about deep learning, machine learning, terms, neurons, layers, various models, and algorithms. And for beginners, we answered that how I started, or working source suggestions, or libraries, frameworks. And this bootcamp goals is to be zero the hero for you. And we want to improve yourself, your project in your deep learning subject. And again, thank you for everyone. Thank you again. Okay, if you next no previous week, you know me, but I I want to summary that who am I? Really, I'm so excited again. I'm Irem, and I am computer engineer, and I especially work for computer vision and deep learning. And I can say that currently I am working on remote sensing data. And I have been working with Google Developer Group and Women Tech Makers team. And now I am organizer Google Developer Group Istanbul and Women Tech Makers Istanbul. And you are seeing my website URL in here. And if you want to connect with me, you can visit my website and you can see my all social media accounts and you can see my contact address. Please, you connect with me, and let's start. Oh no, this is previous week. 1 minute. So sorry, 1 minute. I opened previous week's slides. And it's okay. I share my screen again. Yeah, now everything is okay. Okay. Really, I'm so excited again. I'm sorry. Today, we will focus specifically on such a baseline model because usually similar and 1 minute. Yeah. Now you are seeing my screen and it's not for all. I'm so sorry again. Firstly, I want to good understand this model, and today in this bootcamp, I will tell what I will tell throughout this baseline model. Today we will talk about data preprocessing, frameworks, learning paths, models, and really, this baseline model will be base for week. And I want to quickly speak of this baseline. And first, we start with data. And you are seeing now. We apply various operations to the data if necessary, Then we pass the data to the model. And again, you see, here we need to know data well, know the process well, and know our needs well. If you know them well, you can process with a good framework selection and that data generator. In fact, most of phase one parts belongs to framework, and operations are done here. And the model is trained with the data we give. And after, in evaluation process begins, and here the evaluation is with our test data sets. And if the results are good, maybe if the results are good, we can reuse the model and model save. And today we will go into the details of this transaction in general. Of course, we split the data. And okay, why? Example, imagine please. We 100 data, for example, 100 data. And of course, we don't put all the data we have in training process. We should split data. And there are some reasons and some rules for that too. In the process, we're talking about 3 parts in general, or 2, train and test, or 3, test and validation in general. Of course, we use the train data set, the train operation, and most of our data is in the train process. And we can say that we usually allocate 70% train data set in generally. And these split rates can, of course, vary. And what should we pay attention to when preparing these data sets? I will come to that subject shortly. Let's quickly explain the validation and test data sets. And validation and test data sets are often confused. Even in academic articles, we can see them used interchangeably, but they are used for different purposes. We talk about trained data sets, and again, we said that we use 70% of our data sets for train. Yeah, but 30% space left from our data sets, and we will use this for tests and validation. But before that, let's get to know the validation and test data sets. You will always see the test data sets split in deep learning processes. And with the test data sets, we measure training success. The important point in the test data set is we never train the test data sets. After the train process, we will use this test data sets, but after the train process. For testing purposes, and the computer will see it the first time after train process. And this is so important point. And validation data sets. It's real confusing, and validation data sets is something not understood. And we are actually doing a validation with the validation data sets. What's mean? We actually get a truth value with the train data set in the training phase, but during the training phase, this doesn't always give us a near accurate result. So we need validation data sets, and we need a validation with validation data sets. So I think I prefer this validation, train validation and test splits. And here we see train, test, and validation data sets in a project. This is an example of segmentation, and you are seeing now. If Aware edit the original image and mask, for example, train image original train image and segmentation mask, validation image and segmentation mask, and more. Introduced all data sets beginning, original image and mask. Show the file paths in the code, and you are seeing now. But in the train phase, it will only receive the train and validation data set, and we say that train and validation data sets for training phase. And after, for testing, we use the test data sets. You can see in this way to rename the original image X train and Y train. X is original image, Y is the mask image, and you can see in this way to rename, and train and mask rename. Okay. And I want to put some segmentation example here. It is going through the dataset example, and you can see multi-segmentation example in image. Building, tree, car, and other legends have different color and different classes, and you can get different color and different legends. And we use the original image and mask. We can make segmentation processes, original image and mask for segmentation operations. And it's Microsoft CAT and data example. A data set that we can use a special classification operations for these data sets, Microsoft CAT and DOT data sets. In this part, I want to talk a little bit about what we should pay attention to when data sets. So important subject. So we can create the data set, or we can use public data. We usually have problems with public data sets. These can be simple mistakes, but there are also mistakes that are difficult to understand. Therefore, training, you should understand the data sets well. It's so important. Data sets well, understand the data set, check it, and preprocessing it if necessary. If you see what kind of problems can we have in problem, sometimes data sets are not well labeled, maybe proper names, or maybe missing masks and images. It's a big problem. But often the biggest problem is, I can say that data is not labeled properly. By the way, it's also good to put a small number of hard to understand data in the data sets. And this is actually a detailed and specific topic. If you are serious, please write in chat. I am reading your comments during the presentation, don't worry. If you want me to explain this subject, because so detailed subject, I'll explain it with exam next week. Please, you write chat. I can see YouTube chat. And some deep learning frameworks. In previous week, we saw some frameworks. These frameworks with detail and framework feature. Oh, yes. In the left, you see some popular framework list, but we have more frameworks, more depth. I want to list most popular frameworks, and these we should see Keras, Tensorflow frameworks, and on the right you can see usage rates softwares in here. And currently, Tensorflow, Keras, and PyTorch are among the most used frameworks in real life, real projects. We have been using Tensorflow and Keras more
Hello? Okay, guys, I'm sorry about this. It looks like Irem is having some issues with her electricity. Give us one quick second to fix this. I'll play some music in the background while she works that out.
Yes, please play the beats, my good man, while I you know while I vibe out a little bit. But how is chat doing otherwise? ABD, Hermes. Hope you guys are vibing. What we can do, we could do show and tell for a few minutes. What is interesting enough to do show and tell? Okay, let's see. Oh, I have this here. It's a Rubik's Cube, but I'm not good at solving Rubik's Cube. I'm learning. Although this has a thing on the back, you could attach this, and you could actually charge it. Why would you charge a Rubik's Cube? Because for this, actually, you can connect it with Bluetooth to your phone, and you could learn how to solve Rubik's Cube. So that's kind of interesting. That's my show and tell for the day. Hope everyone enjoyed that. Yes, and Hermes, you're using Python? You know, you could use Python. I personally wouldn't recommend it. You know, if it were up to me, everyone in the world would be using Java. You know, literally, you could do everything using Java. The SCFIU. I hope you're not saying that on behalf of the entire DSCFIU, because that's that's a blanket statement. Okay. Java is for winners. I mean, except if you're doing AI, which Iram will be teaching you guys. Probably some Python and whatnot. Thank you, David. JavaScript got Java in the name. It's all good. Oh, and joining back the call is our future guest.
So interesting. They really. Today I saw small fire on my computer, and again go to electric and wait me please. Few minutes.
No worries at all. No worries. You're up. It happens.
I will come a few minutes later. I'm so sorry, really.
It is okay. Don't worry about it at all. We're all just talking about our favorite programming languages right now. Some people in the chat say JavaScript. Some people say Java. Some people say Python. Do you have a favorite language, Urem? Do you like Java, Python, JavaScript?
Of course, Python.
Python. Wow.
I know your favorite Java.
Yes.
Your workshop.
I was hoping you would have said Java, but it's all good. It's all good. I respect you for using Python. People like Lazaro though need to just go to Java, but it's okay. You could use Python.
Oh.
Yes. But yeah,
my slides updated and.
Oh, no worry about it. Everything Python for life. Come on, DSCFIU. You sure you really feel that way? I mean, maybe I could convince you different, you know. There's so many different things you could use Java for, you know. Like I'm sure you could do machine learning in Java, you know. I haven't really heard of it, but you know, you could, I'm pretty sure.
Oh,
Actually, Iram, have you heard of anyone using Java for machine learning or deep learning?
yeah, of course. Of course.
Really? See, Iram, the expert herself, has confirmed it. You could do everything in Java. That I rest my case. I rest my case. Yes, and then when I sell my $14,000 Java course, you know, I'll include a section about machine learning. I'll learn it just for the course. So you know, stay tuned, everyone. Just because you could do it doesn't mean you should. I mean, it's worth giving it a try. You know, I know Sunri, someone on our server, he created some model in C++, or he used PyTorch in C++, as far as what I remember. So it's, you know, it's possible. Java, import java.util.tensorflow. Oh, that's so cool. You could use TensorFlow in Java too. I actually want to try that out, honestly. That sounds so cool. Welcome, Natalia. Good to see you. Glad you could join us. Yes, everyone. Glad to see you all in the chat. Yes. Hope everyone's enjoying their day. It's a nice day outside. It's Python. Interesting. Very. Generally use C#, and C# is better than Java and Python. Ooh. C#. That is a new contender. I know C# is used.
Web backend.
I'm sorry.
Web backend for backend. Web backend.
Yeah, makes sense. I thought everyone loved Python. You know, I'll be honest. I have used Python in the past, but it's been a while since I used Python. And in our university, the FIU, Florida International University, they mainly teach Java. So you to an extent should have to like Java to get through the curriculum at our school. 4 years of it. But Python is cool. You know, I'll just say it for this live stream once, please. I hope no one's recording me. You know, Python is good. Python is good. To a certain extent, it is slower than Java. You can't deny that. I do not like the indentation rules in Python either. See, in Java, you don't have to indent at all. You know, you have to you just include the brackets and that's it. Python, you have to be very specific about them. Yeah, no language is better than the other. True, they're all just ways of translating algorithms or translating the way we think, except for Java, you know. Everyone is free to use whatever language that they like. Even if you want to code in binary, I'm sure machine learning is possible in binary, or or if you want to do it in machine code, that's all good. Might just take you a little longer, but
can you host authentication?
yes,
Candida.
of course. Let me do that right now. Yes, you should have co-host right now.
Yes.
Oh, Python could be faster than Java if you use the right tools. Well, good to know.
Are you okay?
Yes, we're back.
Really so interesting day, and really I'm so sorry for everyone. Okay, we say that some deep learning frameworks and most important frameworks, TensorFlow, Keras, PyTorch, and PyTorch. PyTorch is a framework that is widely used, I see, in academic studies, and of course, it's also used startups and special projects. And I am a research-based engineer, and I can say that I have seen PyTorch, especially in academic studies. And when you choosing a framework, maybe I say that I don't forget. What tools it offers you and how it receives and process data are very important for choosing a framework. And TensorFlow, today's subject, and so important framework for us. And yeah, today's subject, framework, TensorFlow. And I think the first framework that comes to mind when it comes to deep learning is TensorFlow. I said previous slides, when choosing a framework, how it receives and process data are very important. So we can think of TensorFlow like this TensorFlow, like data flow. A tensor is often thought of a generalized matrix, a multidimensional matrix. So we can call the multidimensional matrix for TensorFlow data flow. And TensorFlow is a Python friendly, not Java, no, Python friendly end-to-end open source library for machine learning and deep learning framework. And of course, supports different languages as are Java, Go, C++, JavaScript, and many languages you can consider are used with TensorFlow. But I must say that it gives its main stable support to Python language. And Python is the most popular language used in deep learning and used in many fields. Really easy to write and read programming language, and this is an advantage for a programmer who writes hundreds of lines of code. Using TensorFlow with Python gives us extra convenience, and it's so important for developers. And TensorFlow was created by Google Brain team. So yes. So this framework from Google, and it's open source framework and ever evolving framework. And being open source is an advantage for us. And open source software is open to development, and we can shape it better on open software. And the fact that TensorFlow is open source means it's constantly evolving, and we can easily develop it. And TensorFlow offers us many ready-made libraries, models, and functions, which means a lot of things are ready for us. So our work becomes easier, and this is still, I think, preferable. So sample codes are also available on the website, and other feature. It's quite easy to use other Google products, as its framework provided by Google Cloud Platform, various Google tools, Colab, and other Google products provide TensorFlow. And all the differences between TensorFlow and other frameworks is the community support. TensorFlow is supported by the communities, which is a good feature for TensorFlow. And you can discuss with people, ask questions, find many more resources about TensorFlow, and also preferable for developers. And of course, community supports a good feature for framework. And now you are listening to TensorFlow and TensorFlow community like this. And in September, I think 2019, the transition to TensorFlow 2x was made. Now, I think the current and stable TensorFlow version is 2.5. And with TensorFlow 2, there are actually a lot of change for us. And that's why TensorFlow 2x is important to us. What kind of changes have happened if we count? There have been very good change, especially in the use of the GPU, and we can see the GPU more and other machine learning application has become much easier for developments. Another one of the biggest change was the TensorFlow and Keras merger. Already, Keras and TensorFlow could be used together, and now we can use it like single framework. There have been choose change to Python in TensorFlow, especially for Python developers, and lost many more models and easier use of function were also good for TensorFlow users. Overall, I think we rank TensorFlow 2x innovations, and that's all. Here you see a training and deployment features graph of TensorFlow. We will actually see what's in the chart in feature slides, and we will talk about it today and next week. What you see here is basically TensorFlow features. Are you aware it's actually quite similar to baseline model we just talked about, and it just told you what could be inside. And let's get down the basics in this model. And first, TensorFlow and Keras merged. We said that with the transition to TensorFlow 2x, TensorFlow and Keras can now be used together. That means more features and more quality, and this is something researchers and developers prefer. Our work becomes easier with more models and more ready-made structures. We save time and cost, and again, so important. Here we see the import TensorFlow and Keras together, and that is like you see. And with the help of TensorFlow and Keras framework, we can easily do various operations. Now you are seeing various operations with TensorFlow and Keras frameworks. Even its process will be other frameworks like PyTorch, MXNet, and other framework. And okay, but how to use these features with TensorFlow? We will see this feature in next slides, all feature, and data preprocessing, models, applications, layers, and more. And all these we can use TensorFlow and Keras with easily. First, preprocessing. We saw data, shortly data preparing, dataset features, splint, and more. And now we are seeing data preprocessing. And why we need data preprocessing is a question. Actually, we data scientists, deep learning engineer, it doesn't matter. We can spend a lot of time preparing the data before creating a training model. Data is not always exactly as we want, so we need some preprocessing process. And preprocessing our data can improve our results, and that's what we want. Image processing could be simple tasks like, and you can see now, in image resizing, removing noise, filtering, pixel brightness, and many more techniques. And this is actual data preprocessing if necessary. And you have to decide which technique to use, and when deciding the needs of your data and what you want are very, very, very important. So important questions. What you want for data, and then data preprocessing. And application, yeah. Actually, first week we saw convolutional neural networks, CNN algorithms, and various models. Today, I want to list TensorFlow Keras applications and against its so important feature. Models make easy for our process, and application help us to process the data correctly and to perform the train process in the most accurate way. And what we want to do, or what results we want to achieve, the characteristic of our data or the needs of our data are very important in the selection of the application. So important question. And that's why we can choose an application looking at or needed. And please read the articles of models, specific articles and models article. And if you want to know more about the applications, and again, next week, if you want, we can talk about a specific model, and we will talk about specific model. For example, RESTnet or VGG, it doesn't matter for me. And this is will be next week subject. And optimizer. Optimizer, it seriously affects result optimizers, and we can use optimizers like ADAM, Ada Delta, RMS Probe, and more optimizers. Each optimizer contains a different mathematical formula, and now you see the formula and codes of the ADAM optimizer now. And we need to choose an optimizer according to the operations we do according to data. Optimizer loss functions, and it's responsible for optimizing our train processes. Yeah. And I listed optimizer in the left side and optimizer example in the right side. You are seeing now. Probably most optimizer you have seen before in here. Actually, every optimizer have different mathematical operations and mathematical equation. And you are seeing one of example. Let's write code in right. What's code in MES? First, we import TensorFlow and Keras. We will use the layers and optimizers that TensorFlow and Keras frameworks offer us, so we need to import them. Then we add sequential models and various layers. You can see. Then add optimizer with learning rate value, and finally model compile with loss function and optimizer, and that's all. And loss function formula, and yeah, loss function. In the previous slide, we saw of the loss function with optimizers. Loss function example and loss function used with optimizers. And we said that the loss function is important for the optimizer because we apply an optimization based on the loss value we get, and those or results are directly affected. So important for results. A loss function must be chosen when calculating the error of the model during the optimization process. And loss function should also be selected according to our transaction, our process, and each loss function has a formula. For example, we can use binary cross entropy in a classification operation whose result is binary. Yeah, result is binary, and we can choose binary cross entropy. But if our output is multi-class, so it will be better to use the categorical loss function. If we need to interpret the code, in this code, actually we saw previous slides, but first we import TensorFlow and Keras. I say that quickly. Then create model and various layers. Then compile model with loss function at optimizer and loss function. That's it. And callback function. I think so important function, so useful function, callback function, and code friendly, developer friendly. We can include various functions that make our work easier in that function and use them during the train operation. Here, you can see error stopping, model checkpoint on and TensorBoard. And to explain a little bit, first TensorBoard. I will explain the TensorBoard in more detail, but I can talk a little bit for TensorBoard. TensorBoard is a visualize for results, metrics, model graph, and much more. I will tell you about the TensorBoard again soon, next slides. And other model checkpoint. With the model checkpoint function, we can take checkpoints during training. For example, we can save every best with a checkpoint on the file we want. So it's so important function. And other error stopping. Error stopping requires the selection of a performance measure. And if our training stops learning, we can use error stopping, and so it's useful and developer friendly function and feature. And we can use the things in callback. It's enough to use the callback function during the fits or train operation to do all these operation, and you can see. And yeah, model fit, and we can use this callback function in here. But now we are not seeing now. Training process, and you can see it's a place where the operation begin, and by using combination of various function layers and features that we have used so far. Here we start the train process with the fit function, and then we give our train image and train mask data sets. We give our bit size value here 2, 4, 8, or different. It doesn't matter. Your computer features and power are very important when determining the bit size value, and you give bit size value here 2, 4, 8, and different. Then we write how many times we want the steps to. We also give our validation data sets in here, and the process begin. And we can see every epoch results, values, and more here. And you can see now. And as you know, there are many fields in deep learning and machine learning. And of course, we evaluate different areas with different metrics. It's so normal because different area. So needs different metrics and different formulas. Each metrics value has different logic and different formula, and I think one of the metric values we see the most is accuracy value, and yeah, accuracy value in here, and most see. And the accuracy value may not always give the most accurate result for us. So we may need different metric values. For example, let's see an example segmentation and the use of metrics on it. I said that when we were talking about metrics, we were talking about a mathematical formula. While talking about metrics, we will see values such as true positive, true negative, false positive, and false negative. And each of them has meaning. And let's learn metrics through a picture. On the left, you see the mask image. And a human created image that the computer did not predict is on the left. Prediction image and ground truth. We call it ground truth and prediction. And on the right, the predicted image is, if you say, what is the predicted image? This is output after train operation. There is a learning during the training process, and after learning, prediction is made, and with the prediction process, we can see how good or bad the learning is. And you are seeing now the screen, and yellow color here, yellow color segmented woman. It's mean yellow for segmented woman, but you see again there are wrong predictions. So long prediction, I must there are wrong predictions in predicted image, did not recognize part of woman, and so wrong segmentation example. And we see again example of segmentation. Even we see their naming in the slides. Blue is actual and gray is predicted area. Actual area and predicted area. And so what do we mean by concepts such as true positive or false negative or other? Actual, yes. Now you are seeing actual, yes, and predicted, yes. So true positive and actual yes, predicted yes, true positive, and gray and blue merge true positive area for us. Or actual yes, but predicted no, false negative in here, and in here predicted no, and actual yes, and false negative area, and this is metrics. Yeah, that's metrics. And other example, formula example. We said we have many metrics value, even we said that metric values have different mathematical formulas. And we were using these metrics value in different process. You can write these formulas in your code, or you can use it by calling with Keras, Tensorflow, and different frameworks or models. You may need to read the documents for this, and then you can call the metrics in codes and metrics and formula example. And it's IOU score example. We have seen metrics over segmentation in examples. So I wanted to give an example of the IOU score metric value. And because we can use especially IOU score metric for segmentation. We can also look at metric values such as F1 score, precision, recall for segmentation. But we can say that we use it especially in IOU score value in segmentation example. If you say which one do we use object detection, I can say that we are looking specifically at the F1 score value for object detection examples projects. Let's interpret example here. We see object detection and segmentation examples for calculating the IOU score value. Area of overlap and area of union. Operation give us the IOU score. Overlap, divide, and union, and gives us IOU score. And of course, other matrix values are calculated using similar but different formulas. But it's for IOU score for segment example. And TensorBoard, I think so used feature. TensorBoard goal is visual debugging. For example, we can monitor our metric values with TensorBoard during the training process. See, our metric values visually makes our work easier. During the process of the train, we saw that many epoch steps were lined up after the other, and these epochs are hard to follow. So TensorBoard provides visualization for metrics value, graph model, histograms of weights, and much more. Even you can see GIF in the right side, and I recommended the use Tensor for easy control and easy tracking for processing, and so useful feature for TensorFlow. Another TensorFlow GS for machine learning on the web. I think one of the features of TensorFlow is that it specifically supports web, embedded, mobile, and much more. And it's offered web area supports with TensorFlow GS. And I think it's pretty good, especially for web and artificial intelligence developers. And TensorFlow GS is a library for machine learning in JavaScript. If we use machine learning directly in browser or in Node.js with TensorFlow GS, we can develop machine learning models in JavaScript. I think if you are web developer and are thinking of starting deep learning, you can use TensorFlow GS, and here you can see some projects made using TensorFlow GS. There are examples that look pretty funny, and you see too. These projects are developments with web and deep learning together, and you can see more real-time projects with TensorFlow GS. And these projects example are on the official TensorFlow page, and you can see URL, TensorFlow page URL, and good test resources, especially for beginners. I can say that. And I can want to include a brief use used here. If you want to use TensorFlow GS, you need to include these scripts or installation from npm tools. And you are seeing now for me TensorFlow GS. Feature and last feature, last topic in this presentation, TensorFlow Lite. We will continue to see other TensorFlow features, TensorFlow Hub, and other. It's example next week. And we say that TensorFlow provides support for web, mobile, and embedded. And TensorFlow Lite is TensorFlow's features for mobile and embedded. You know, Lite features are preferred on mobile and embedded devices. So TensorFlow Lite is a set of tools to help developers run TensorFlow models on mobile, embedded, and IoT devices, and use many mobile apps. And so we want various features to mobile application, and minimal power usage, lightness, speed, and more. And deep learning operations are actually heavy operations, but with the use of TensorFlow Lite, we can develop applications in a more light way, and TensorFlow light supports light way, so important for mobile and embedded developers. You can find many more examples, by the way, on the TensorFlow official website, and you can see URL. And I think, again, it's pretty nice example to start by trying. And even I started by trying ready-made codes at the first time, first stage, and starting with such experiments, but increased my motivation and made me learn faster. So I recommend you to look at these examples as well, and you can try this course on Android, iOS, Raspberry Pi, embedded devices, and it's already appears here, and you just have to visit the link here and this link and examples. And actually, that's all I have to say for this week. And today, especially, we saw TensorFlow and TensorFlow features. And we even went over baseline model, and we covered the issue in depth. Sorry for the internet for some reasons. So for electric problems, really, I'm so sorry. And anyways, thank you for DSC FIU team and listeners. If you have any question, please connect to me, my social media accounts, or my website URL. You can see iramkomurcu.com. My all social media accounts on the website. Please, I wait for your question. Thank you for everything. And again, I'm so sorry for problems.
Iram, thank you so much for the whole presentation, and don't worry at all about earlier. Thank you so much for the amazing workshop. And I know people in the chat definitely really enjoyed the workshop. So thank you so much, and for everyone in the chat. We'll go ahead and send, yes, Lazaro has sent the website where you can find all of Iram's contact information and reach out to her if you have any questions about presented. And stay tuned for part 3 next week. We'll be going even deeper and learning even more. So stay tuned, and I'll be the final part to our series. Thank you all so much for coming. And yes, and also, yes, make sure to, I see a few of you are joining our Discord. Make sure to join in our Discord and stay connected with DSC as well for more updates and more information on future workshops as well. Thank you all so much.
Thank you.